we are going to discuss the classification algorithms based on neural networks. At the end of this session, the student will be able to demonstrate various classification algorithms based on neural networks and compare between them. We have to understand what is a neural network. An artificial neural network, or normally called as neural network, is a mathematical model of computation based on mimicking the biological neuron. In other words, it is an emulation of this biological neuron system. Why do we understand neural networks? Because they are useful for data mining and decision support applications, and people are good at generalizing from experience. Computers excel at following explicit instructions over and over, which are making it to do a repetitive task. Neural networks bridge this gap by modeling on the computer and how the human brain actually works. The characteristics of these neural networks are they are useful for pattern recognition or data classification through a learning process. Neural networks simulate biological systems. Now, when we understand this anatomy of the neural network, we know that a neural network maps a set of inputs to a set of outputs. And here the number of inputs are decided and are variable, and the network itself is composed of arbitrary number of nodes which are called as hidden nodes and finally produces a particular output. A neuron has many inputs but produces only a single output unit. The output can be excited or not excited, and therefore it can be used for classification, giving an output or not giving a particular output. This is the motivation why we understand neural networks. Since we generate an output or we do not generate an output, classifying it into two classes. The incoming signal is from these particular neurons, which are determined if the neuron is excited or fired. The output is subject to attenuation in the synapses, and which are junction parts of the particular neuron. There are many topologies, but the basic topologies are feed-forward networks, which are unidirectional, do not have feedback, and do not support cycles. The second type is recurrent networks, which is bidirectional and having a feedback attached. We train these particular neural networks to give us a particular output, and we adjust now these inputs, and we keep on changing the weights which are given to this particular input, because it is this weighted sum which is going to give us our final output. Now let us pause for a while and think how neural networks are going to help to do a classification. Neural networks are frequently used to a great extent in data mining. The simplified process of training the fast feed-forward neural network is as follows. You input data into the network, it propagates right up till it reaches the output layer. This forward process produces a predicted output finally. This predicted output may be a measure to tell us which particular class this output has to be categorized into. The predicted output is subtracted from the actual output, and an error value is found for the particular network. The network then uses supervised learning, which is the most cases is backpropagation, to train the network to produce a particular output. Desired outputs are produced by adjusting the particular weights, and this all is then encountered in the last hidden layer, okay, which is then given to the particular output. Once backpropagation is finished, the forward process has been completed. Backpropagation is the common method of teaching artificial neural networks how to perform. So the backpropagation algorithm is used as a layered feed forward, and backpropagation algorithm uses supervised learning, which means that they provide the algorithm. The techniques which are used are: present a training sample to the neural network, compare the network's output to the desired output, calculate a particular error, and for each neuron calculate the output and a scaling factor. How much lower or higher has to be adjusted to match the desired output. This is a local error. Adjust the weights of each neuron and lower the local error, and then assign a blame for the local area to the neurons. Okay, so that we have an output generated with stronger weights, and repeat the procedure until all neurons are visited. Every node has input weights attached to it, so we get a weighted sum, and we add a bias to this particular mapping so that we generate our particular output. A simple perceptron either fires or does not fire depending on the particular output. Okay, so it generates at the particular output a 0 or a 1, dividing it into two classes for classification, and hence we can use neural networks for classification. So this is how a simple perceptron works. First we initialize the weight, then we put the input into the particular system, then we generate a particular output, we find out, we update the weights, we do this recursively, okay, until all samples are classified, and then we return a particular value as fired or not fired. The advantages is it has high accuracy. Neural networks are able to approximate complex or non-linear mappings. Noise is reduced, tolerated, independence is done for the prior assumptions, and there is ease of maintenance to use neural networks. We could use this to classify various tasks for the problems of finance, a higher financial institute and a lower financial institute. Okay, could be two classes of finance. Okay, then we could use it for marketing, we could use it for human resources, we could use it for accounting, where classification forms a basis on solutions for these particular problems. There are no general methods to determine the optimal number of neurons to be given as the input for solving any problem. So this becomes a design problem. It is difficult also to select the training data set which fully describes the problem to be solved, because our testing data set is going to be dependent on the model that is created by the training data. How do we improve this artificial neural networks? By using some optimized algorithms like genetic algorithms or a neural fuzzy system to get our desired output. For our references, we have used the textbooks which are recommended. Thank you.